we will solve this system of equation using the matrix form. So we have the matrix 1, 9, 9, 1. So let that matrix be the matrix A. And we will use eigenvalues and eigenvectors to solve this matrix equation. All right. So first we find eigenvalues. Determinant of A minus lambda I equal to 0. So we find the determinant of the matrix A where we subtract the lambda on the diagonal. And we find determinant, which will be 1 minus lambda square minus 9 square equal to 0. That is 81. And multiply it out. Lambda square minus 2 lambda plus 1 minus 81 equal to 0. So the equation is lambda square, the characteristic equation, lambda square minus 2 lambda minus 80 equal to 0. That is the characteristic equation. When we factor out, we should have lambda minus 10 and lambda plus 2 plus 8 equal to 0. So we have two eigenvalues. One of them is 10. The other one is negative 8. So those are the eigenvalues. Now we find the eigenvectors. Which we will solve this equation. A minus lambda I V equal to a 0 vector. Right. So first, for the eigenvalues of 10, we have the equation determinant. Sorry, this is in the vector form. A is 1991 minus lambda minus 10 on the diagonal times the vector v, v1, v2 equals 0, 0. So we have negative 9, 9, 9, negative 9. Of course, because it is 2 by 2, one of them should be the multiple of the other. And I do reduce row echelon form. It should be 1, negative 1, 0, but just do that anyway. Right, second matrix. Again, for TI-84, we can do this. TI-83, we have to store the matrix. Sorry, alpha zoom. 2 row, 3 column. Okay. By the way, that is. Let's start again. Alpha zoom, 2 row, 3 column. Negative 9, 9, 0, 9, 9, negative 9, and 0. 1, negative 1, and 0. Right. Only the first equation is significant. So we say V1 minus V2 equal to 0. So V1 is V2. So when we write the equation, write the solution, V1 is just V2, where we can factor out V2, and we have the vector 1 and 1. And that is our eigenvector. The first eigenvector is 1 and 1. Next, for the eigenvalues of negative 8, the matrix is 1, 9, 9, 1. Minus lambda on the diagonal minus negative 8 is a plus 8. So we will have 9, 9, 9, and 9. From here we can say just 9v1 plus 9v2 is equal to 0 because those two equations are identical. So we just pick one. But anyway, if we do the reduced row echelon form, put that in the calculator, we should have just 1, 1, 0. So the first equation gives us v1 plus v2 equal to 0. So v1 equal to negative v2. If we put in the vector form, we have negative v2, v2. Factor out v2. We have negative 1 and 1. And that is the second eigenvalue. Right. Once we have the eigenvalues, the eigenvectors, we can write the solution. The solution is the linear combination of e to the lambda t times v. So we write the general solution. The vector x equal to c1 e lambda 1 t times vector v1 plus c2 e to lambda 2 t vector v2. Right? C1 lambda 1 is 10. Vector v1 is 1 and 1. Lambda 2 is negative 8. Vector is negative 1 and 1. So that is the solution in the general solution in the vector form. I actually just multiply this out and combine it into just one vector. So we multiply the first one, we have c1 e to the 10t, c1 e to the 10t plus negative c2 e to the at, negative at. And then c2 e negative at. And then we add them. We will have c1 e to the 10t minus C2 e to the negative AT, C1 e to the 10t plus C2 e to the negative AT. That is also a different form of the solution. By the way, we're not done. On this problem, we are given the initial condition. When t equal to 0, the vector equal to 7 and negative 1. 7 and negative 1, that is. So x of 0 is 7 and negative 1. Right, so from our last solution, we're going to put 0 in for t, and so pretty much because e to the 0 power is equal to 1, so when we put 0 in, all the exponential function equal to 1. So we just have, when t equal to 1, just have C1 e to the 10 times 0, which is e to the 0 power, which is 1. So we just have C1 minus C2, C1 plus C2 equal to 7 and negative 1. Of course, we can write the system of equation as C1 minus C2 is 7 and C1 plus C2 is equal to negative 1. But just keep the matrix form, and instead of writing the equation, system of equation, we just keep the matrix form of 1, negative 1, 1, and 1, C1, C2. We keep the matrix form, and let's do the reduced row echelon form as well. Right, I just want to switch that to the CTI 83. I can just store the matrix, second matrix. Let's store that into edit matrix C. So hit number 3. 2 rows, 3 columns. 1, negative 1, 7. 1, 1, negative 1. Quick. Then we do the reduce row echelon form onto that matrix C. Just under names. So C1 is 3, and so this is C1 and that is C2. C1 is 3 and C2 is negative 4, and we're going to substitute back into this form of the solution. So finally the solution is x equal to C1 will be 3 e to the 10t, vector is 1 and 1, C2 is negative 4 e to the negative AT, the vector is negative 1 and 1. Let me zoom out and see it, and recap the problem. Again, we write the equation in vector form or matrix form. Write out the matrix A, find the eigenvalues, the eigenvectors, and eigenvectors and eigenvalues put together, we have the solution in that form, and that is the general solution. And this problem, we are given the initial value problem, so we can substitute back when t equal to 0, and in this case we have again the system of equation either in the matrix form or in the system of equations. And we should be able to solve for the constant. In this case, we have C1 is 3 and C2 is -4. Substitute back into the general solution, we have the solution to the initial value problem.